I'm Omar Khan. I'm a senior software engineer at Ripple, and I'll be presenting my journey of creating a decentralized crowdfunding platform on the XRP ledger using hooks. So the goals of this presentation is to, like I said, discuss my developer journey with design, development, and then I'll show a demo at the end. And this is to help developers to go from 0 to 1, not 0 to hero. There's not enough time to cover how to become an expert in 25 minutes, but just enough to get started. And this is what I mean by 0 to 1 and not 0 to hero. All right, so let's just first discuss hooks, right? So what are hooks? It's a smart contract proposal for the XRP ledger. They're small, efficient pieces of code being defined on an account that allows logic to be executed before and or after a transaction. So you can think of it as a middleware transaction, and they're primarily written in C. They're compiled to WebAssembly, bytecode, and then finally installed onto an account. And now let's talk about the app. So the objective of this decentralized crowdfunding platform is to, provide a decentralized way to crowdfund campaigns, right? And so you can think of this as a decentralized version of Kickstarter or GoFundMe, so where there's no central authority that controls flow of payments. These payments are transparent, visible, and they can be seen on the ledger. And then there's also backer protection, where backers vote on the use of funds or when refunds should be issued. And before we dive fully into the application, let's go over the terminology. So this is similar to what Kickstarter or GoFundMe has, where you have a campaign, which is a project to be funded. You have a creator who creates it, and then you have a backer who funds a campaign. And then you have milestones, which are campaign goals that must be met to demonstrate progress. And so backers, what they will do is they will evaluate the milestone progress, and they will either vote approve or reject to continue having the campaign to be funded or to get a refund and get their money back. And this happens when a majority vote happens for either approving a milestone or rejecting it. And then the milestone payout is when a milestone gets approved by backers, then the creator can claim the reward for it. And yeah, there are 3 phases to a campaign. One, we have fundraise, where we raise funds by its end date, and if that does not happen, then the campaign fails. And then, but if it does happen, then we move on to voting on milestones. And like I said, backers vote on milestones. So majority vote. If they reject a milestone, they can get their money back, or if they approve it, then the creator can get the reward payment. And then once all milestones have been completed and paid out, then the campaign is successful. And so I took this model from Pledge Camp, which is a decentralized crowdfunding platform, and I just pretty much implemented it in my app. So you have creators, you have that create campaigns with milestones, you have backers, and backers will contribute funds to a campaign, and then once the fundraise is successful, they can vote on each milestone. So for example, let's say that milestone 1 gets approved by all backers, and a creator can claim the reward for that milestone, and there's a percentage associated with it. However, if milestone 2 fails, then backers can get a refund based on how much funds are remaining in the hook account for the creator. And yeah, so why use hooks for this app? So hooks provide a smart contract use case, and this is definitely perfect for a decentralized crowdfunding platform where donations, rewards are all transparent, and they're publicly recorded on the ledger, and the payment flow is decentralized. So the hook smart contract logic solely controls how payments are emitted, how they are accepted, rejected. And also democratize voting, right, for backers, whether they want to vote a milestone gets approved or rejected. All right, so let's go over the rules and constraints of hooks, right? So a hook account is an account that has a hook installed on. And so this account programmatically controls a payment flow based on its smart contract logic. So this can either approve, reject incoming transactions, emit new ones, and also save data to its state or even delete it. And so you can install a max of 10 hooks on a single account. And the hook transactions that I'll be using for my app are setHook and invoke. So setHook is the transaction that installs a hook onto the account. And like I said, max of 10 can be installed on a single account. If more required, you would have to use multiple accounts with foreign state. And there's a fee associated with it, which is one owner reserve fee and a variable length transaction fee. And that's based on the hook execution count. And then you also have invoke transaction. This will trigger a hook to execute. So a hook can't automatically emit new transactions. You have to trigger it. So this is where this transaction comes into play, where you can have it change its hook state. You can emit new transactions. And then you would send the application data inside of a blob field. And there is a fee associated with it, which is 1 drop per byte and 128 KB limit. All right. So now going on to the hook state, which is allows application data to be saved onto the hook account. So this is going to be visible on the ledger, and you'll be able to query that data too. And it's a map data structure that's used for storing key value entries. So the key is 32 bytes max. Value is 256 bytes. And that's subject to be changed based on validator voting. But currently on testnet v3, it's 256. And like I said, there's a hook state entry fee. So for one owner reserve fee, or actually for one entry, it requires one owner reserve fee. And this can store up to 2 to the 8 to the 32 entries. So if you do the math, that's virtually unlimited. But it gets expensive as more entries are saved to its state. And you also have to do loops and guarding, or guarding within your loops, where hooks are not deliberately like Turing complete. So that means that the fees and execution operations, they must be deterministic. So, and if you look on the right, there's an example where we're writing a loop in C, and we have the guard function that takes in 3, meaning that that's the max number of iterations it can do. Otherwise, it will throw an error. So, and yeah, for a single hook, you can do 65.5K operations or instructions. And if it exceeds that, then you would split the logic into multiple hooks. All right, I've covered a lot, so now let's go into the software design. And here are like the components I'll be discussing. All right, so let's look at the application operations. So we need to determine what operations will be needed for this app, right? And one way to ideate these operations is to pretty much write user stories, right? So for example, as an owner, I want to create a campaign to raise funds for my project. So that can translate to being a create campaign operation. And then you would write similar user stories for all the other operations on the right that you see, right? For view campaigns, fund campaign, voting, and requesting payments. And then we need to create the models, right? So these models will determine what data is needed to represent this app. And as you write out the class fields, you want to keep in mind how much space this would take up. So for example, campaign title would occupy 75 bytes. And yeah, here's an example of like the models that I just wrote out, where I'm just using JavaScript to define the data types, but and then I also like wrote out like how many bytes or like UTF-8 characters each one would take up as I'm going and writing this out. So now we also need to define a serialization protocol. So when you're sending data in an XRP transaction, it's encoded in hexadecimal. So for example, the memo field on the right for this payment transaction, you can see this is all encoded in hex. And so the hook will decode this hex and execute logic based on it. So therefore, we need to design a protocol for the hook to decode it and for us to serialize it, and vice versa. And what I did was I pretty much just wrote out like data types that would be used with my application model. So for example, campaign ID, it would be uint32, which is 4-byte unsigned integer, which would demonstrate or represent destination tag. And then campaign owner would be an XRP address, which is a 36-byte string with its length prefixed. And now, like going into the hook state design, so like I said before, it's a map data structure. So The key is 32 bytes, value is 256. And for each entry you add to the hook state, it requires one owner reserve fee. So we need to create a design that is space efficient to minimize fees. And so how can we do this with this constraint, right, where the key is 32 bytes? So what I did was I just used the leftmost 28 bytes to be the data lookup flag. That identifies what campaign information to look up. And then the rightmost 4 bytes, I set that as a destination tag, and that uniquely identifies the campaign. And so here is a visualization of the hook state key design, where you have the data lookup flag on the left, and then you have Cafe Babe on the right to be the destination tag. And then the composite of that will be on the bottom, right? So with this key design, you can have 2 to the 8 to the 4 campaigns created. So that's like roughly 4.3 billion campaigns. So I think that's quite enough. And then for each campaign, like the types of data that you can look up, it's 2 to the 8 to the 28 entries, which is definitely a lot as well. So this looks like a good design. And now let's cover the hook state entry value, right? So the value is 256 bytes. And we use a data lookup flag to determine what type of information to look up, right? So if it's set to 0, then we're just looking up at like the general information of the campaign, right? Like, for example, what are the milestones? What's the fundraise goal? What's the funding amount? And then, but all other values within that range, we store fund transactions. And for each value, we can store 5 transactions. So it's sort of paginated. So for each entry, you can query 5 fund transactions. And that goes up to a maximum of 2 to the 224 fund transactions. And so, yeah, this is kind of complicated to look at right now, but this is pretty much the key value design of my hook state. And yeah, each row represents an entry, right? Like number 1 is general info, the flag is 0, data lookup flag, and then you have the destination tag. We're using Cafe Babe as an example. And then, as you can see, this entry has a general campaign information. And then the second entry contains fund transactions, and it's the page of transactions which contains this data that's listed on screen. But wait, who's actually paying for these fees? So this reminds me of a quote from a wise man, Milton Friedman. He said, "There's no such thing as a free lunch." And an even wiser person, my Pakistani mom, she tells me there's no such thing as free biryani. So somebody's got to be paying for it, right? So let's look into this. And so the hook state entry fees. So recall each entry requires 1 owner reserve fee, and currently on the testnet, the owner reserve fee is 0.2 XRP, so very small. So for creating a campaign, that initially requires actually 2 entries. But the first entry is to store the general info about the campaign, and then it prepays for the first fund transaction entry. So that includes, or that just goes to a total of 2 owner reserve fee, which equates to 0.4 XRP. So it's very cheap for a creator to pay as a campaign deposit. And then for backers, this will require 0.04 XRP, which is 1/5 of an entry value, because like I said, each entry for a fund transaction is paginated. There's 5 transactions, so if we evenly distribute that, that'll be 1/5 of the entry value fee. So that comes out to 0.04 XRP. And yeah, so now we look at what transactions we'll need to implement these operations, right? So we're going to use payment transaction for creating the campaign, which includes a deposit, and also for funding the campaign. And then for invoke, like I said before, hooks can't automatically be triggered, so we need to use it for voting, for requesting payments, and in each transaction, both payment and invoke, we include the destination tag to indicate which campaign ID we're referring to. and then sending this application data to a hook. So like I said, it must be serialized in hexadecimal, and you can use the hook parameters field for a SecHook transaction with up to 16 parameters, and the fee is 1 drop per byte. And then for payment, you can use, which already exists, a memo field, 1K bytes limit. Or you can even use the hook parameters in any transaction now. And for invoke, what I use in my app, I just use a blob field, and yeah, that's 1 drop per byte, 128 kilobyte limit. So this is an example of the serialization where you have this JSON application data, and then with my protocol, it gets encoded into this hex. And then this hex gets set to the memo data in a payment transaction, and the destination tag is a campaign ID. And so pretty much what I'm doing is I'm creating a campaign with the ID of being a destination tag, and all of the fields for the campaign that I set are encoded in the hexadecimal in the memo data. And then similar for like the invoke transactions, we need to encode them as well. But what I did was I just used the blob field. So for example, we have this vote reject milestone. It gets encoded into hex, and then again, it's referring to the campaign ID by using a destination tag, and then it submits a transaction. And then for off-ledger data, we want to include, I guess, fields that are not required by the hook, and which won't require like data to be saved to the hook state. Because like I said, we need to be space efficient with how we save data, because the more data we save, the more fees it will require. So this includes fields like title, description, URLs, and also yeah, the milestone title. And yeah, and we also need to make sure we have a script for each type of payment, right? So for payments, I created my own crowdfund_payment.c that only accepts payment transactions, and then similar for invoke transactions, we have crowdfund_invoke.c. And so yeah, these scripts get compiled to WebAssembly and submitted into a set hook. And yeah, these don't try to read the code, but these are the hook scripts that get compiled to WebAssembly and sent in a transaction, the set hook. All right, cool. Now let's move on to the demo. OK, so let's go ahead, and I'm going to show you the raw data that's actually saved onto the hook state. So here, I'm just using account info and namespace entries to query this data. So we have this hook account here with this address, and we're pretty much querying the ledger data on it. So what we have are 15 items right now, and each item is a hook state entry. And so as you can see, you have the key right here, you have the value here, and they're all encoded into hex. And so if you go and now try to decode it, yeah, this is a process data. So it gets the entries from the hook state, and then as you can see, it decoded the data lookup flag, the destination tag, and then it decoded the value, which is this hex decoded into this fund transactions, which has yeah, the account and then the amount that was actually contributed. And so now let's go to the application. So here are all of the campaigns that pulls from that ledger data that's on the hook account. And so let's just try to like fund a campaign with an account. So right now we have this hook account. And let me see. I just want to show you first. If we go to the Hooks Explorer, we can look at all the transactions for this hook account. And I'm just going to show you the actual set hook account or the set hook transaction that was done. So here, this was my hook code. So this is for like the payment one. Yeah, this is all encoded into hex. And then this one's for the invoke, right? So as you can see, it's installed onto this hook account. And let's go ahead and try to see which one we can like contribute to. We can contribute to all right, this one, right? So let's switch account. So Let's do one, go with Rachel. And then we can see there's only one person who contributed, Ashley. So let's go ahead and help out this campaign. Let's do 50 XRP. It's kind of hard when I can't look at my laptop. 1, 2, 3, 1, 2, 3. So this is in drops. So let's go and fund that campaign. And as you can see, the amount was raised, and it wasn't the full 50 because of fees, but now we'll see that Rachel, which is my account, we contributed like about 50, and then we can look in the Explorer that we sent that payment to the Hook account. So yeah, 50. And then we used the destination tag 387 to identify that campaign, and that went through. Okay, cool. And now let's try to actually claim a payout. So we have a payout available for this one. We'll switch over to the Daniel account, who is the campaign owner. Daniel. Okay, so let's go ahead and claim this payout, and we're just going to do the invoke transaction like I showed before. Cool. So it looks like it was paid out, and let's go ahead and check out that transaction. So we go to Daniel on the Explorer. And as you can see, he first did an invoke transaction to request that payout, and then it was approved by the Hook, and it sent the payment to claim the reward for that milestone, just like 25 XRP. And then lastly, let's just go and create a new campaign, right? So we could even like switch it to a different user, Melissa. So let's create a campaign. And just to save time, this is the campaign data that I'll be using to create it on the Hook. So let's go ahead and create that. OK, so now let's try to find it. Right here, yeah. This is a campaign to become a halal samurai with a VR experience. But and so you can see Melissa's owner. And we'll see on the Explorer that, yeah, she sent a payment transaction to create a new campaign with a destination tag of this. And then the data is actually encoded in memos. If we keep going into it. Yep. That's the campaign data. And that concludes my demo. So let me just quickly go back to the slides now and just wrap this presentation up. So slideshow. OK, done with the demo. Right, so to get started and just setting up a Hooks developer environment, I actually created a repo, Create Hooks app, where it's available on my GitHub. And it's gotten some good feedback, especially Dennis Angel. He really liked what I did with the app. And so if you want to quickly set up the environment, you can just clone this repo and just run one command for it. And then here's a cheat sheet. This is all recorded, so don't try to like memorize it right now. And then here's a real-life story. Ripple partnered with the Berkeley's Masters of Engineering project. So I actually proposed this project, and I created the backend for them to use. And what they did was they created a UI that integrates with the Hooks app that I created, and it was working. And that's what they built on the right, the UI. And yeah, almost done. A huge shout out to and thanks to Richard Holland. And he's my Hook sensei, and he's the one who helped me develop this app. And yeah, let's connect. My LinkedIn and Twitter is on there, and I'm open to answer any questions that you have. Yep. All right, I think that's about it.